I'm going to do only 2 today, 14 and 15, so make sure you're there. Okay, ready for 14. Got calculators. Here we go. Come on, let's go. We know the drill. Even though I don't think you need them here, but you'll need them for stats, obviously. Okay, for 14, which expression is equivalent? Look, worst comes to worst. What can you do? Always do. Plug in. Now you're going to have to plug in your own numbers for x and y. Avoid 1 and 0. Okay? I don't want to do it that way. I want to do it mathematically. Whew, boy, I know a lot of you would probably think I'll start distributing and see which one it is, but we're not. This is not a distribution problem. Okay, this is not a distribution problem. It's actually, believe it or not, a factoring problem. Okay, why is it factoring? Ready? Look at your subtraction symbol right here. What do you notice on the left and the right that they have in common? What do they have? Tell me what they have in common on the left, and don't tell me x's and y's. Get more specific, please. 4x to the fourth minus 16. Everyone see they have that in common, the left and right. That's your GCF. You're taking that out right now. So pull x to the fourth minus 16 out right now from both sides, the left and the right, and I want to know what you are left with. All right, so pull it from the left side. What's left? Pull it from the right side. More and more calling on you guys, so let's start this off with lucky number 4. I pull out the x to the fourth minus 16 from the left. What's left? Great job. And then I pull it out from the right. Minus 9. Got it. Quick scan. Is that one of my choices? Nope. So that must mean, that tells me keep going. Keep going. Keep going here. X to the fourth minus 16. That's the difference of two perfect squares. I believe in you. I think you can do this. Factor that one more time. 2. Can you factor that one more time? Well, you're missing something. Because that was x to the fourth. So don't just leave it x and x. Leave it x squared minus 4, x squared plus 4, yep. And I realize you guys don't think you can do anything to this second parenthesis, but you can. You see a 9 there, right? You see a y to the fourth. And probably the sticking point is the x to the 6th. It makes you believe that you can't go any further. But you can. Hey, as long as the exponents are even, it's a perfect square. As long as the exponents are even, it's a perfect square. So here we go. I think you guys can do 3 and 3. Plus and minus. What am I going to turn x to the 6th, y to the 4th into? They're both perfect squares. Divide by 2. Go, Aid. Yep. As long as the exponents are even, it is a perfect square. Is that up there? Quick scan, everybody. Is that choice up there? Maybe not in that order, but is it up there? Choice 4. I'm not done because I need to prepare you guys for every single scenario. You can still keep factoring. I know the choice is there. It's number 4. Great. We can still keep factoring. Out of the 4 I have up here, which one can I keep factoring? Here you go. 5. Out of the 4 options I have up here, which one can I keep factoring? There you go. It would be what? X along with everything else just written. Okay, I can't factor any of those. Okay? Just want to prepare you for everything. That's the battle we're going to face. You guys good there? All right, that's tough, right, at the beginning? So hopefully you guys plugging in a non-0 or a non-1 for X and Y work if you need to do that. All right, here we go. Eyes. I learned the hard way 5th period that depending on who you had, you either memorized the eyes or you used the clock. Well, then you didn't use the clock. You memorized it then. It's one of the two ways you learn. You either memorized it or you did the clock. So I won't do the clock because I don't want it to mess with some of your heads that have never seen it. All right, I got A, I got B, and I got C. I need your guys' help. A minus BC. What is it asking me to do to B and C? Okay, let's do that off to the side so that doesn't get involved with our problem. Let's do 4 minus 2i times 1 plus 6i off to the side. Do not plug a number in here, okay, because you're talking about an I, which is an imaginary number. Do not plug anything in for I. All right, going to need a little help from number 12. Here we go, 12. 4 times 1. 4 times 6i. Got it, going good. Negative 2i times 1. And negative 2i times 6i. Don't go ahead of me. Just let me know what it is. Don't. Don't change it yet. I just want No, I got you. I like it though. Just leave it I squared because we got to review that though. We got to review. Okay, one thing you can do for me, Lauren, can you clean up those two middle terms?
Oh, the two middle terms.
Yep, combine them. 22i. All right, everyone good? Before I get into this whole I business. We all good up here? All right, you guys remember from last year, I squared was the same thing as -1. Yep. So that's going to be 4 plus 22i. What's this now become if that's -1? Plus 12. Keep going. 16 plus 22i for BC. All right, ready? What was my A? What was A? -3 plus 5i. And here, look, we just did a whole bunch of great work, and it's not going to mean nothing. It's not going to mean anything unless we remember this. A lot of you are just going to put up minus 16 plus 22i. Oh, I'm done. And that answer's up there too, by the way. I want you to do that. Answer's up there. Fall in that trap. But the only thing you are subtracting right now is 16. It wants you to subtract BC. Not 16, BC, all of it. So now it's going to be, yeah, it's still going to be minus 16, but plus 20. -3 plus 5i minus 16 distributed through minus 22i. You had to change the signs in the second one. And this is why this test drives me nuts. Because you guys hopefully will be working so hard that you do all this great stuff here. You forget to put the parentheses around it and distribute the negative, and that answer's up there. Pick me, pick me. That's what it's saying. All right, because you screwed up. All right, finish it for me here. Combine your like terms so we can move on. 9, move on here for me. -19, got it. Plus? -17i, got it. Which would be choice 3. And but choice 4 is what you would have gotten without the parentheses. Okay? Everyone good there? Questions, anything? Today's Regents Review, 5 weeks away from Thursday. Yep. Plenty of time, right? Okay, have your packets out. I got to make sure we are good to go for this quiz here. If you don't know how to use your calculator tomorrow, I can't help you. Okay, I can't help you. Yep, a lot of it's going to be calculator based tomorrow. Can you use the calculator? Go to your packet. Go to, I'm going to do the first question in the assignment. Whatever, I don't know where this page is. It's the first, what do you got there, Zen? What do you got? Page 9, yep. I don't know why I do this, doing problems you should have already done, but I want to make sure you're good to go tomorrow. So I was given this average table and frequency. I don't have time for you guys to put it in your calculator. I already did. Hopefully you know how to do that tomorrow. Okay, how to put where and how to put these values in the calculator. So I did my 1var stats. Here are the screens I got. All right. I could put a full screen on there, so I divided it up there. All good? Tomorrow, how do you find the range? Part A, how do I find, actually, I'll just do it up here. How do you find range? You don't need the, shouldn't need the list for this. 1, how do I do range? Okay, go ahead. What 2 numbers you're subtracting then? Minus 65. Go ahead, let your classmates know what's the range here. 34. Yep, done. I don't know if I'll ask something that easy. Quartiles. Here we go. There's my screen, by the way. There's my screen. All right. Quartiles. So Q1, you can read it right off there if you want. Here we go. 1 again. Quartile 1. I need to make it bigger. 84. Everyone always goes to quartile 3. There is one in the middle there. It's called quartile 2 or the median, which is what, Aiden? Let's go. 90. Yep, you got it. Quartile 3. 95. All from the calculator. All from the calculator. Letter C, what's the interquartile range? Got to know that formula because that won't be found on the calculator. Got to know the formula, though. IQR, interquartile range. 1, oh, again. Yeah, bro. Here we go. How do you find interquartile range? Yes, it is. Q3 minus Q1. Okay. Pretty easy when you know the formula and how to use your calculator. Ooh, here we go now. Population standard deviation. That's on the calculator, but which value is it? And we are going, I'll go nearest 10th for you. Nearest 10th. Which one is the population? 1. 1.
So we know that OX is the entire thing. So then that means population. So it's the OX. It's 8.2.
8.2. What's the, right here? Everybody, I'll highlight it in green. Population, right there. Yellow. What's the yellow one here? That's sample. I am going to ask for either one tomorrow. And if no one is asked, if none is either asked, we assume it's the population. Okay? We assume it's the population. All right, E here. Probability that a teacher randomly picks a student in the 70s. Not 70, 70s. In the 70s. Probability. Something out of something. In the 70s. 9. 3 out of 35. Good. If you're asking where'd the 3 come from, that's 1 plus 2. Do not just count how many scores. Oh, there's 2 of them. No, there's not. Count the frequency. And then yes, where do you get the 35 from? Yes, you can add up your frequency column, or you calculator savvy kids that want to remember this, that n equals, that's how many scores you have. Okay, you calculator savvy ones that want to do it that way. All right, here's where we left off, and I left off pretty quick with it on Friday, is this last part, which is how many students are within 1 standard deviation away from the mean. Mean is what, according to my tables up here? Mean is 88, right? And I want to know within 1. So that means above or below 1. Anybody remember how we found those? How do I find the score that's above 1 and score that's below 1? Lauren, what's up? What's the 8.2? So ready? You add standard deviation to get 1 above. So everyone go ahead. 88 plus 8.2. 96.2. And then how do I go 1 below? Subtract the standard deviation. 88 minus 8.2, which would be what? 70? 79.8? Yep. So any score between those two is considered within 1. So count them up. And what are you looking for? Just how many? Not probability, not percent, just how many. So go ahead, add them up that fall within that range.
Sorry, what are we adding up?
Within one. So anything between 79.8 and 96.2. And we got there by adding the standard deviation and subtracting it from the mean. Keep adding if you're adding. How many scores are there? 1. How many scores?
95. That's 4. 4. 7. 2. 16. 2. I think that's all of them. Might be 25.
25 scores, yep. Okay. Can we all do this tomorrow? Along with some other stuff too, like population versus sample. You guys remember the truckload versus the pail of oranges? Controlled experiment versus observational study. A couple questions on those, but this is basically where I'm staying tomorrow, along with what I'm about to do right now, which is something new on the calc. Anything you want to ask? And plus, there's obviously more practice questions along here if you want to keep going with those. Yes, sir, it is. Yep. We don't have many days to fool around with, so I can't have a gap day. Anything? We're going. You ready to go today? Something new on the calc? Everyone take SATs or ACTs? Okay. Correct me if I'm wrong. When you get your score back, they also tell you what percent you fall in. Is that true still or no? Or am I just too old? Touche. They tell you you're in the 65th percentile, the 71st percentile. They still do that nowadays, or? Okay, so just a quick update on where they get that percent where you fall. They use this curve here, which is called the normal curve. So on a certain day, everybody takes the SATs. They calculate the mean. Okay, and if you add up all these percents, they add up to a 100, and everyone see how it's symmetrical on the left and the right at 0? Okay, 0 is the mean. The median, 50% below, 50% above. So I don't know, what's a good average score on the SATs? I don't know anymore. 1,100? 1,000?
I think average is about. There's like
Average is
I think it's 1040s actually.
Okay, can I just say 1,000, just so it's easier for me? Okay, so they calculate the mean. Say it comes out to be 1,000. So they put it right there at 0. Then they calculate the standard deviation. Okay, whether it be population or sample, they calculate a standard deviation. So let's say it's 100. Okay, let's just say it's 100 for now. So let's say for this particular SAT, it's 100. So what they do is they take 1,000, they add 100, and they get to 1,100, and that's one above. So if you scored an 1,100 right now, this percent of kids scored at or below you. And this percent over here that you add up scored at or above you. Okay? Now let's say you got above an 1,100. What do they keep doing? They keep adding the standard deviation. So guess what's at 2? The score of 1,200. So if you scored 1,200, whatever this percent here is, as you add up left to right, that's the percentile you're in. Well, what if you scored less than 1,000? How do you think they get this number at -1? 900. They subtract 1,000. Okay, so you draw a line here and you say, all right, you add up this, that's the percent of people who took the SATs that scored 900 or below. Okay, so that's what they do, and that's what we're going to do today. All right, I'm going to give you the mean, I'm going to get to the standard deviation, and what I want from you guys is what percent of kids scored between here. What's up, Ben? In between, yep. So if I want to know what percent of kids scored 900 below, 0.1 plus 0.5 plus 1.7 plus 4.4 plus 9.2. Okay. If I want to know the percent of kids who scored between a 900 and 1,100, I add up everything in between those two. Okay. But do you see how we get these scores at the places? We take what's at 0? What's that 0 here? I know 1,000, but that's my what? That's the mean. And how do I keep going here? I add the standard deviation, or if I want to go to the left, I subtract it. All right, I think we're ready to go. All right. Set of measures follows a bell curve. Stop right there. Bell curve says, hey, we can use this bad boy right now. We can use this curve. All right, we can use this curve right now. On this particular test, the mean was 80. So where should I put the number 80 right now? In the middle at 0. So 50% scored above an 80, 50% scored below an 80. And the deviation is 5. That's my standard deviation of 5. What percent of kids fell between 75 and 80? So I need to find on the curve where's 75, where's 80 on here. Well, I already know where 80 is. So is 75 going to be to the left or to the right of it? To the left, all right. So as I go from 0 to -1, what do I do with 80? The standard deviation. I subtract 5, and magically, what do we end up with? All right, we're picking this up. That's 75. So I don't need to do any other numbers. So now what I'm going to do is I'm going to take it from -1 to 0, and I'm going to add those percents up. And that's the percent of kids on this particular test that scored between a 75 and an 80. So what is that, 15 plus 19.1? Okay, what percent of kids fell between there? 6. 34.1% of the kids who took the test got between those two grades. I don't know what it is. That's embarrassing. Okay, guys, good. Not too bad so far. Good? Okay, let's go through 2. Just make sure you got it down. A set of scores with a stop. Ooh, yeah. Normal distribution. Curve, curve, curve. Bell curve. Normal distribution. This curve is called the normal curve. All right, so if you see normal distribution, I'm using this curve. Mean was a 50. Where do you want to throw that 50 on? All right, all right. Standard deviation of 7. What percent fell within 36 to 64 now? So where on the curve is 36? Where is 64? You want to go above or below first? Below, okay. So if I want to go to -1, what do I got to do with the 50? Go ahead, subtract 7, and we're at? Still not good enough, right? Because I need to know 36. So what your suggestion? Keep subtracting 7, and we'll go to 36. That's at -2 now. We don't need to worry about the halves. 36 at -2. Ready to go above? 50 plus 7 at 1 is 57. Not good enough. Need 64. What's going to be at 2 above? 64. Yep. All right, so everyone see the percents we need to add up. Everything from -2 to 2. Everything within there. Good, good. Everything within 2. I'll let you add your numbers up. Six when you're ready. Woo! A lot of kids, right? 95.4% scored. And that went from where on the curve? -2 to 2, right? I want you to remember that number, please. 95% is always equal to within 2 standard deviations. Okay? Because we're going to do a couple problems here by the end of class that you're going to see. You got to find the actual range when I give you 95%, and you see 95. Oh, that's at -2 and 2, right? That's at -2 and 2. There's another percent I want you to know, which is 68%. That's going to be within 1. So if you add the percents from -1 to 1, they'll get about 68 and change. Those are the 2% you need to be aware of when reading these problems. Oh, kids, I like you. I like some of you a lot. So this is going to kill me to tell you this. This is going to kill me to tell you this. Let's just read through number 3, and I'll break the bad news. This is nothing different than 1 and 2. Mean normal distribution. We're thinking the big curve. Mean is 72, standard deviation is 7. What scores percent was 65 or higher? No big deal, right? Okay, bad news. Nobody's giving you the curve. That curve you did for the numbers 1 and 2, you're never going to be given it. It's not on the reference sheet. So does that mean I'm going to ask you to memorize it? No. Come on. Absolutely not. Luckily for us, it's programmed in the calculator. Now look, when I say programmed in the calculator, I don't mean like there's some special button and this curve is going to come up with all these percentages nice and beautiful. That's not what I mean. These percentages, though, are in your calculator. So here we go. Where do I find this normal distribution curve? Everyone, nope. It's just Sarah, can I stop, please? Everyone see this VARS button here? Do you see what is written above it? Oh, DISTR, which is short for distribution. Let's go. Second, VARS. Now, there's a lot of choices here. We're only going to live at one choice for the remainder of this unit, and that is number 2, normal CDF. Normal CDF. Okay. Now, you hopefully, do we have, I'll get that. That's from last period. Get these out of there. Does everybody have lower, upper? We all good there? Do we need to update a calculator or two here? Everyone's got this now. Okay, go back to the problem for me before I tell you what to fill in. We're looking for what percent of scores are what? Look, 65 or above, right? Okay, let's go back. Then what do you think my lower bound is going to be of range? 65. So lower 65. Upper. See, that's the thing. No, I don't know if it's a 100-point test. So yes, we got to tell the calculator to put infinity in there. All right. How do we write infinity? We put in the largest number the calculator can handle. Ready? 1. Everyone see where'd it go? There it is, above your comma. You got the double E's. Second comma, 99. That is 1 times 10 to the 99. That's the biggest number your calculator can handle. So anytime you need a positive infinity, that's where we're going. Okay, this next one is the mean. The U is the mean. So that's in the problem. What is it? Read the problem. It's there for you. 72. And I believe we've seen this bad boy before, or part of it. Yep. Standard deviation. Yep. Which is 7. Yep. Okay. Everyone good with these values? Okay. Paste. It'll paste those values right into the calculator for you for normal CDF, and you'll get this number out. That is your percent, but as a decimal. If you want the actual percent, what do I need to do? Multiply it by 100, and I believe it gives me rounding directions here, doesn't it? Yeah, oh, it's multiple choice, so it's going to be about 84%. Okay, so your calculator, instead of you adding up the percents under the curve, your calculator will do it for you. Any issues here? Because this is where we're going to stay the rest of the class, but just some different things you're going to plug in instead. All right, go ahead, read through Arlington High School, the SAT scores. Where is it? Where is it? If the scores of the exams were normally distributed. Calculator now. No more curve. Calculator, remember. Normal CDF. Here we go. How do I get there again? Second VARs. Which one do I want to live at? Normal CDF. Okay, now got to read the problem here. Sue scored 740 on her math. What percent of students who took the exam scored below her? So what's my, in words, what's my range right now? In words, what's my range? 740 or below now, right? Hold on, no. 740 or below. Ready? How to plug that? Are we okay on what we're finding? Okay, how to plug that into the calculator now. Now what's my lower? Negative infinity. So instead of putting 1, negative 1e to the 99. What's that? And then now what's your upper bound in this problem? To 740. Good, we got it. Mean? 540 with a standard deviation of 80. Paste it. And it's what? To the nearest percent? 99%. Now, just a quick comment. I know you're using the calculator. All right, I get it. But when you do this on the Regents exam and the quiz tomorrow, I just can't see 99 and that's it. You might just have good eyesight for all I know. Okay, I can see around you. So what can you show for work? Right there. Right there. Exactly what you're, so negative, here's what you would do. Negative 1e 99, comma 740, comma 540, comma 80. There you go. That's what I need to see for work. Okay? Good there? If it's multiple choice, I don't need to see any work, but. All right. Feeling confident? Good. Because now all we're going to do now is take your percent and do something with it. Just don't give me the percent. I want you to do something with it now. So how about the sodas? The amount of soda in a can is normally distributed. Check, check, check. Mean of 12, standard deviation of 0.6. If 250 soda cans were pulled, how many are expected to have less than 11 ounces in them? All right, what's my range here? In your own words, what's my range here? From what to what? This and above, this and below. What's my range here? Okay, so 11.1 and below. That's my range. Good? Okay. I'm going to turn this over to you guys now once I go to second VARs myself. Normal CDF. Okay, lower bound. What are you plugging in for the lower bound? 7, lower bound. Okay. Bathroom break kills us. 13. Here we go. Negative 1e 99 already up there. Upper bound. 7. That's how many cans. That's not my range of what I'm testing. 11.1. Mean in this problem. 12. 12. With the standard deviation of 0.6. Paste that sucker. So what percent of cans are going to have 11.1 or below? About 6.68%, right? 6.68%. That's not what I'm asking for, though, and obviously that's not a multiple choice. Because I want you to do something with it now. 6.68% of how many cans? 200. Oh, boy. Of how many cans? Of 250 cans. So now that's what I'm asking. Can you guys find 6.68% of 250? You can, hey, if you didn't multiply it by 100, just leave that number in there and multiply it by 250. So about how many cans?
17.
17 cans. Yeah, buddy. There you go. How's everybody feeling, all right? That's about as tough as I'm getting. Find the percent and do something with it. No need for clapping. All right, little change up before we end the day, little change up. I'll give you the percent. What's the range of scores then? Okay, you guys have, your calculator has always figured out the percent for you. Well, I'm going to give it to you, and I want to know what the scores have to be between that. Normally distributed. All right. Means 56, standard deviation is 5. Which interval do approximately 95.4% of all cases lie? Your calculator's not going to do this one when they're given the percent. But, oh, how about that percent? How about it? How about it? 95. 95. So that tells me it's got to be within what? -2 to +2. That's what this problem's telling me with the 95%. From -2 to +2. So a quick little sketch of our own curve. Yeah. 12, here we go. What's at 0? Which is? 56. Remember what I got to get to. +2 and -2 for 95%. Can you get me those scores? Yeah, you can. Dig deep. 3. How am I getting to +2? Twice. I add 5. I get to +1, which would be 61. Add 5 again. 66. Yeah, who's going backwards now? 3 again. Yeah, let's go. Okay, so if I subtract 5, I get 51. Subtract it again. 46. So what's the range of scores that 95% fall in? 46 to 66. Yeah. Yep. Nope. Questions? Got no time for that. Other questions? Breathing's optional. Everyone good so far? Because we're going to do a little review for the quiz right here at number 7. 20 high school students took an exam. I want to know what percent of students scored within 1. Remember what within 1 meant. Now, it doesn't say normally distributed, does it?
No.
Okay, so no curve. Curves out. Curves out. Within 1 means I'm going to take the mean, whatever the heck the mean is, and do what? Add 1 standard deviation and subtract 1. Where am I going to get all these numbers? List. Let's go. Little review going into tomorrow. All this is going into one list. There should be no frequency list here. And you should have 20. So the next one that's blank should say L21. All right, make sure you got 20 in there. 20 in your list. Check it, because you type like you text, remember. There's no autocorrect on this calculator. And then you should be going to your 1var stat screen, picking off the mean. That frequency should be blank. You should just have L1 blank, because there is no frequency list here, so don't tell the calculator to look anywhere else. How we punch it in? We punch it in all right? Ready to see if we all got the same mean? Uh-oh. Did we get the same mean? Anybody brave enough to let me know what they got for their mean? About 79.7. I have 79.7. Gotta be careful what you're typing in, young buck. Be careful what you type in that list. You're better than that. What, Patrick?
Did I not like? Because you already told us in one standard deviation.
See, you're doing the 68.2%, right?
Yeah.
But that's for normally distributed scores. Nowhere up here did it say it was normally distributed. So I can't assume it's 68%. Might be another percent. Good? Okay, ready? All right, stop. Standard deviation. What are you guys getting for the ox? About 8.7. Yeah, that's what I'm getting, about 8.7. Okay, here you go. So what's the score one above? For one above, 79.7 plus 8.7. What do you got? Yep. So 88.4. And what about when I go one below the mean? About what? 71. Okay, so are everyone ready? We got to figure out, because it says what percent. How many total scores are there? 20. So out of the 20, how many fall between 71 and 88.4? Take your time. Circle them. There's a good idea. Cross them out. Triangle them. How many are between 71 and 88.4? Anybody have how many? 14 out of 20. It does, that's probability. Great job, but it said determine what percent? 14 out of 20? 70%. Maybe when you guys get older, I'll show you how your calculator can put these numbers in greatest to least, least to greatest if you want. Never mind. Okay, I'm caring.